Good day to Doctor and my fellow friends. I'm Victor Yongweitek, metric number AF200134. My group member consists of Wu Yuting, Ho Zijong, Tan Min Kai, Go Zhenzi, and me. We are from Section 1, Group 4 for the subject Foundation Engineering. First and foremost, we are going to describe our company profile. TJTH Consultancy is a consultant-based company that established since 2005 and located at Johor Bahru, Johor, Malaysia. Our vision is to be a leading force in the engineering consultancy by setting new benchmark of innovation, sustainability, and excellence through the usage of computer tools and software. Our mission is to provide the unparalleled engineering consultancy services and deliver innovative, cost-effective, sustainable solutions to our beloved clients. Figure below shows the organization chart for our company. I'm the director for this company with the help of my assistant director, Go Zhengzi, and experienced civil and structure engineer, Wu Yuting. Not forget also for geotechnical engineer, who is the backbone for the field of geotechnique, who are Ho Zijong and Tan Min Kai. Next, the project description will be defined in this chapter. The overview of the project is to construct a 3-story bungalow houses with an area 11.58 multiplied with 28.28 meter. A big thanks to our client that given the golden chances for our company to design the substructure and the superstructure of the houses. The site location for our project is located at lot 10232 to 10235, Jalan Putrajaya 17, Taman Putrajaya, Mukim Simpang Kanan, Daerah Batu Pahat, Johor. There are three objectives of this project. The first one is to evaluate the appropriate type of the foundation uses for this project, either shallow or deep foundation. Second is to establish the design consideration, bearing capacity and settlement of the site project. Lastly is to determine the necessity for the soil improvement at the construction area.
Hi everyone, I'm Tan Min Kai, metric number AF200130. Today I will continue to present the soil analysis. A soil profile it can be derived from the lab tests like actable limit, particle size distribution, and unconsolidated undrained triaxial test, and it is summarized in the table below, which shows a snapshot from the site investigation report. For example, the borehole 1 and the undisturbed sample 1, the depth is 1.5, the moisture content is 22.7%, the liquid limit, plastic limit, and plastic index is 51%, 32%, and 19% respectively. For the particular size distribution test, the gravel is 14%, the sand is 44%, the silt is 15%, and the clay is 27%. Table below consolidate the soil profile details for a comprehensive perspective. While this figure forming a robust foundation for stakeholders to understand the soil properties and composition easily. For example, from 0 meter to 1 meter is a topsoil. From 1 meter to 4 meter is the medium brown gravelly sandy silt. And this trend goes down as shown as the figure below. Next, we proceed to the analysis of bore log. A bore log is created by the driller or geologist, which is the documents geological formation encountered during the borehole exploration. In our project, Geotech Engineering Sdn Berhad will lead the site investigation. Various SPT hammer impacts the end value, crucial for the soil strength assessment. To standardize the end value, it is normalized to multiplying with the energy transmitted to the rod ratio. Addressing hammer efficiency difference, the N60 safety hammer remains uncorrected, while the automatic hammer typically 80% efficiency need a correction to normalize the N60 with a 1.333 factor. The formula is as shown in the figure below. Figures below shows the correlation table for the field procedure of SPT and value. The correlation table for field procedure of SPT and value regarding gamma saturated and gamma D, and the correlation between the angle of frictions and standard penetration number. Finally, the bore log data can be gained after the N60 has been calculated. The average finger action can also be calculated, and it is 32.04. Next, we proceed to the next chapter, which is the column load. Columns are classified into different pad footing groups. Consideration including the proximity, shear foundation system, and load bearing capacities. This group makes it easier to design the foundation effectively and guarantees that the load from the column is in the same group and can be distributed and managed appropriately. In this project, we have 18 types of pad footing with different breadth and length and different height, as shown in the figure below. The project also entails a total of 21 columns subjected to railing load ranging from 97.4 kN to 1842.2 kN. These columns are strategically categorized based on their load bearing capacity, as shown in the figure below. Next, we proceed to column load analysis. P1 and P2 has the ultimate axial load less than 150. The column C1 has the highest ultimate axial load with 105.7 kN. P3, P4, P5, P6, P7, P8, P9, P10, P11, and P12 has the ultimate axial loads from 150 to 750 kN. Column 17 has the highest ultimate axial loads with 707.1 kN in this group. The ultimate axial load for P14, P15, P16, P17, and P18 is more than 750 kN. Column 12 has the highest ultimate axial load with 1842.4 kN. Finally, we come to the summary on column load. Column C1 and C2 has a loading less than 150 kN. Column C18, C15, C9, C14, C11, C3, C20, C7, C6, C21, C5, C19, C16 has the loading ranging from 150 kN to 750 kN. The column C8, C4, C10, C7, and C12 has the loading more than 750 kN. This is the summary on column load, and that's all from me. Thank you. I will pass to my group mate. Thank you.
Good day, Doctor. My name is Uyutin with metric notes AF200155. Today I'm going to present about the design of foundations. This soil profile is obtained based on the SI report. In the soil profile, we can clearly see that the groundwater level is above the pad footing. Also for the soil, the depth is about 30 meter because at the 30 meter, the hard strata is mid, which is clay. Next is ultimate soil bearing capacity. Since our design is shallow foundations, in this calculation we use the Melhoff equations. By consider the soil profile, it shows that the groundwater table is above the pad footing. It is categorized as a case 1. In case 1, the effective surcharge must consider the water. In the findings, we obtain that the ultimate load bearing capacity is larger than the axial loading, which means that the shallow foundation is acceptable to withstand the load from the column. Next is settlement of the soils. Since our clay is normal consolidations and the groundwater table is located above the pad foundations, so there are 3 types of settlement that happen. First is elastic settlement, which add directly to the soils, followed by primary consolidations and secondary consolidations. Next is the overall pad footing for the 3-story semi-detached house. From the findings shows that all the pad footing under the semi-detached house is fulfill the criteria of load bearing capacity and the settlement of the soil.
Hi everyone, my name is Ko Zhengzi, metric number AF200146. Now I'll present my part, which is justification of the design foundations of 3-story semi-detached house in Batu Pahat, Johor. The justification will discuss the soil improvement and whether it is necessary to use it for our design foundations. The different methods used for soil improvement in shallow foundations serve specific purposes aimed at enhancing the geotechnical property of the soil to ensure that the stability and load-bearing capacity necessary for supporting the structures. Compaction is commonly employed, which involves applying mechanical force to the soil to reduce voids and increase the density. Grouting techniques, vibro compactions, deep dynamic compactions, stone columns, and preloading with vertical drains are the techniques for soil improvement in shallow foundations. The overall purpose of these soil improvement techniques is to optimize the foundation's load-bearing capacity, reduce settlements, enhance stability, and create a more favorable ground conditions for construction. This is the summary of the design of foundations. The allowable load-bearing capacity values for both the maximum and minimum column load are more significant than the load imposed by the column itself. And this means that the shallow foundations with different footing size has been selected as it can withstand the load imposed by the columns. After analyzing the settlement for both the maximum and minimum loads of the columns, it has been determined that the settlement is acceptable and the column does not require any modifications of the soil. That's all for me. Thank you.
Next, I will show the drawing of our project, which is 3-story of semi-detached house.
Good day to Doctor and my fellow friends. My name is Wu Zhijiong and I will be presenting conclusion. Based on the finding from the standard penetration test, the soil unit weight and average friction angle were obtained. The analysis categorized the columns into three groups. Shallow foundation is selected after a series of calculations on bearing capacity. The types of shallow foundation for each group are as follows: square footing for group 1, straight footing for group 2, and again square footing for group 3. In settlement analysis, elastic settlement, primary consolidation, and secondary consolidation are encompassed. The total settlement for each pad footing is determined. As for soil improvement, it was determined that the settlement is acceptable and the columns do not require any modifications. This guarantees the safety and stability of the structure.
That's all for our group. Thank you.